In this video, we have to understand the concept of pod disruption budget API resource. So this is my Kubernetes cluster, kubectl get nodes. I have two worker nodes, and let me show you the resources. Kubectl describe node, worker node 1. So this worker node has two CPUs and about 16 GPU of memory. This is in kilobytes. So, and if I show you worker node 2 also has two CPUs and about 4 GB of memory. Okay, so now to implement the pod disruption budget, we have to understand the concept of resources. When we are deploying some application, so those applications, some application need a specific amount of resources, CPU and memory. And that CPU and memory can be spanned on specific number of pods. And each pod is occupying an amount of CPU and memory defined in the resource request. So that those resources are mandatory for some applications. Mean a minimum number of pod and minimum number of resources are mandatory for some specific applications. If application goes with the less number of pods than the desired amount, then the application will not responding. If you read this whole documentation, you can get the idea what type of those applications can be and how and what are there are some very useful examples given here. So by using the pod disruption budget resource, we can use the minimum available or maximum unavailable amount of pods for for the deployment, replication controller, replica set, stateful set to to make sure the minimum available and maximum unavailable. So it depends on your type of application, I mean the minimum requirement of the pod. So let's start. We will create a deployment. Under this folder, I created these two manifest, and this manifest is a deployment for an application that is using Nginx image, and its request I set to 2 GB and 4 millicore of CPU. 4 millicore mean one CPU core is equals to 1000 millicore. So it's mean two pods, three pods will use more than one core, and our worker node has only two cores. So it's mean if we are running four pods, so maximum we can run four pod on a worker node because five pods need more than 2 millicores. So it's mean the four and fifth pod will go to other worker node. Similarly, 2 GB memory we have, so memory we can also calculate with this way. So I will deploy this application and with this amount of request, and this will create multiple pods on different worker nodes. kubectl apply -f kubectl get deployment. I did in the default namespace. You can see it's going to create, and it created 5 resources, and the sixth resource is not going to create because sixth one is in pending state because 5 into 2 12 GB of memory is occupied is required for 5 pods, and the amount of CPU is also not able to provide it by this cluster. So I show you -o wide, you can see can see three are on worker node 1 because worker node 1 has more memory, worker 2 has less memory. So only one port goes to worker node 2, and worker node 2 has CPU, but worker node 2 is not able to provide the memory. Worker node 1 has memory, but worker node 1 is not able to provide the CPU. So now our deployment is stuck in this state. I mean, the last pod is not able to schedule. And if I show you kubectl uh, describe this pod that is in pending state. So here we can see 0 out of 3 nodes are available, insufficient CPU and insufficient memory constraints stop this pod to be scheduled on 3 nodes. One is master node is already tainted, so the schedule is disabled. Rest of all 2 are not able to schedule this pod. Okay, no problem. This is not our problem. In our application, 5 pods are up and running. Now think like minimum 5 pods are mandatory for this application. If less than 5 pods are there, then this application will not work. So we have to make sure the 5 pods are up and running. But due to human errors in our professional life, it is quite possible that so while maintaining our cluster, sometimes we need to drain our nodes for the hardware and software upgradation or maintenance. So in that case, we can drain more nodes that could cause the downtime of some specific application. That example I gave you, that like this application need minimum 5 pods, and if less than 5 pods are there, this application will go down. So now if I do kubectl drain worker 2, so I must have to add this ignore daemon set, and you can see this node is cordon as well as drained. So if the pod I show you here, you can see the pod. Now 2 pods are in pending state because worker node 1 is not able to provide more resources for additional pods that are going to schedule. That is, scheduler is trying to schedule on worker node 1 that is available, and that worker node 1 is refusing that I don't have the resources. And the drain is also doing the cordon. If you are confused about the drain and cordon concept, you can go to the previous videos of Kubernetes cluster, you can get the better idea. So now this is the situation, and we have 4 running pods, and due to drain our application is down, and the administrator that is managing this cluster was unaware about this dependency of this application, and this application goes down. Now how the pod disruption budget API resource can help us to make sure this application, this should not be happen. So first of all, I will do kubectl uncordon my worker node so that scheduling is back to work. So now you can see it is scheduled on worker node 2. Okay. Now I will create a source pod disruption budget. This is a kind pod disruption budget. This is an API resource. Let me show you kubectl API resources. And here, in among all the resources, there is a so this is the resource pod disruption budgets. Short form is PDP. PDB that is available, and the manifest I created from this documentation. If you go down, you can get some useful samples of this PDB where we can define minimum available of pods and maximum unavailable of pods for some specific deployment. So here, when I did the deployment, so this deployment selector name is app web is equal to web app. And this PDB, in this PDB as a reference, I define the same selector. Mean this deployment will be controlled by this PDB, and minimum available pods are number of 5. We need 5. And this is the name of the PDB. You can set any name. So, and it will apply on the default namespace where this in the same namespace where the deployment is working that you want to protect by using the PDB. So let me apply kubectl apply PDB web app kubectl get PDB. You can see minimum 5 is defined here. If you do the more detail, you can do describe PDB web app PDB, and here you can see current are 5 and desired are 5. Max total are 6 controlled by this deployment. But minimum it will make sure that 5 are available. Now if I do kubectl train worker 2 by using an ignore daemon set, so you can see now the error here. When evicting pods, this pod is trying to evacuate from this node. It is trying after every 5 seconds in the default namespace. Cannot evict pod as it would violate the pod disruption budget that will reduce the number of pods, and it is also calculated that it is not schedulable on the worker node 1. If we have any other worker node 3 that contains more resources and it is schedulable there, then it will drain out this resource. So PDB is calculating the whole cluster resources and the relocation requirement of the resources, and based on these calculation it is deciding. So now our I'm doing control C. If I look kubectl get nodes, our node is set to cordon, but the evacuation does not happen. Why? Because PDB stopped this. If I look into pods, so 5 out of 5 pods are up and running. Same if I try to do to worker node 1, same will happen because my worker node 2 does not contain the enough resources to hold all these 4 pods. So same is happening when evict pod is not possible, violating the policy. So this is the use case where we make sure our application minimum number of pods to make some specific application up and running. I just use a very simple application. You can apply this formula for any specific application according to your environment. So now these nodes are cordoned, and when we are doing the train, cordon will also happen. So kubectl uncordon worker node 1, worker node 2, so that if some less resource application is going to be scheduled, it will be. So this was the concept, how I hope you got the idea. how does this whole stuff work? You can try by adding one more worker node, and then if you do worker node 1 and 2 drain, and if worker node 3 has more resources, it will be drained. It will not blocked by the stopped by the draining of the worker node by it will not stop the draining of worker node 1 and 2. So so this is all about the PDB resource.